Thank you, Adam. And great to be here again and be hosting one of these panel sessions. I always enjoy it. As you said, Marijn Bezuijen, I look after the development and deployment of artificial intelligence applications and the platforms for Shell's asset base. So across upstream, integrated gas, and downstream manufacturing. But this panel is not about me. This panel is about the panelists that we have with us today. Hi, everyone. Really good to see you again. Happy to have you with me. I'd like to ask you all to just quickly introduce yourself to the audience, and then after that, I'll talk you through how we're going to run this panel. Manas, can I start with you?
Of course. Hi, my name is Markus Pathak. I am with Intel Corporation. I am Global Strategic Business Development Manager for Intel AI Alliances. In oil and gas, I have led energy initiatives for around AI and Intel, and my PhD and all of my background is in oil and gas. Thank you.
Thank you. Then Ken, over to you.
Yeah, hi everyone. Ken Nguyen, I'm with BP. I'm Principal Portfolio Manager for BP's digital organization. Currently, I'm overseeing major capital projects. My involvement really with artificial is to take artificial, working with academic institutions like MIT, and rolling it out into the use of immersive technology and digital twins.
Great to have you here. Reza.
Hey everybody, it's an honor to be here. Reza Honey, I'm the principal data scientist with Apache, overseeing the modeling, development, and deployment of AI solutions for the business side. My experience and background comes partly from oil and gas, but mostly in technology, startups, venture domain, in different subject areas, goes from trading, imaging, psychology, etc., but focused primarily on AI.
Good to have you here. Abul, over to you next.
Hi, good afternoon from Bergen, Norway. So my name is Abul Fahimuddin. I work at Equinor. Currently, I'm working as a product manager and responsible for what we call an ideation machine, essentially a citizen data science platform enabling us to create value from AI applications across the business area. So my background is by training, I'm a numerical mathematician, and I get excited with data, algorithms, and large-scale computation. So I'm really excited to be with you here today and share our views about AI application, how we're going to scale it, or how we are scaling as we speak.
Welcome. And last and definitely not least, Sara.
Hello, everyone. It's a pleasure to be here today. My name is Sara Cerruti. I'm a member of the Global Customer Transformation Team at Servicemax, where I help our customers derive value from their investment in field service management solutions. Prior to joining Servicemax, I spent 20 or so years in the oil and gas and energy sector, driving business process transformation and digital transformation initiatives, primarily in support of service and field service organizations. It's a pleasure to be here.
And great to have you here as well. I'm going to just direct myself to the audience. Everyone in the audience, this session is for you, right? This is not a presentation. This is a panel discussion. That means we'd like to make it as interactive as possible. Please do use the chat function that's available in this auditorium to ask any questions that you would like. You could either indicate specifically which panelist you'd like to ask a question of, or if not, then I will direct the question to one or two of the panelists, depending on the topic. But in order to get the session started, I do have some specific questions for the panelists. And Manas, is it okay if I start with you again?
Go ahead.
I'd like to ask you, hey, we've been doing AI in the oil and gas industry for a while now, right? It's still somewhat new, but it's not completely new anymore. From our experience to date, what have we seen that has worked well, and what has not worked so well?
Yeah, so I mean, if you look at AI in oil and gas, I like to bucket this in two categories, right? So there is one which is very, I call it narrow AI. These are the applications like intrusion detection or pipeline monitoring. Uh, the use cases span across multiple verticals, multiple industries, but we have very smartly used them in oil and gas as well. And these narrow AI applications, I think, have done a lot of otherwise mundane job, have turned them into very automated jobs. So I think the narrow AI has worked well so far in oil and gas from what I see. Now there's this narrow AI application that can span in the geoscience domain as well. So for instance, talk about a seismic interpretation. So you can have a fault segmentation model. It's a 3D unit kind of model that you can use and automate the identification of faults across your 3D or 2D seismic sections. Again, I would call it a narrow AI application, very specific to something like a immediate problem statement in mind, and you're solving it. Now, what has not worked is, and frankly, this is something that would probably happen in future, is the broader AI. The super intelligence, like how do you connect these different systems of systems and do an automated, jobs of finding oil and gas that spans across seismic to reservoir, connecting all the domains, etc. I think that's yet to be seen. What has also not worked is if you blindly trust AI. I believe in oil and gas, it's more augmented intelligence than artificial intelligence, meaning you have to have a human in loop. It could be a subject matter expert, a reservoir engineer, or a seismic expert that would look into what AI output is, as opposed to blindly trusting what AI is predicting or these machine learning models are predicting. So I think there is that aspect of it, which is, I believe, should be very well received, because we have a lot of domain expertise in oil and gas that needs to stay in oil and gas and use AI as a supplemental tool rather than 100% trusting AI in these domain-specific use cases.
Thank you, Manas. Ken, I'm going to move to you next, if that's okay. And building a little bit on what Manas just said, how do you think AI will, what role do you think AI will play in the future of oil and gas? Which processes in the oil and gas industry do you think can be accelerated by the application of artificial intelligence?
Yeah, so I think the opportunity is huge for application of AI in oil and gas and the future of it. So I'll focus on one area. Clearly, there are things that Marijn has said in regards to intrusion detection, but I'll focus on production and operation, right? Which is the exploration and kind of operations of these facilities, whether it's onshore, offshore, or new energy. So I think the opportunity is there is that we'll take the traditional kind of AI, which is based on machine learning, deep machine learning, that requires an algorithm to be set to develop and kind of analysis out, but it does still involve a human being to find that. And as we move towards more of this cognitive AI and this interpretive AI, I think that's where you begin to see real dramatic changes in the way that we produce energy. Right. So one of the areas that, for example, I work in is the ability to incorporate this technology into the use of immersive technology or digital twin to help us build and operate. So what I think where we can get to, and I don't think that's too far in the future, is to get to a place where you have what I call a self-healing, self-operating facility, right? Because an AI system now has access to all of our data, whether it's IoT data, whether it's pipeline data, any of that data runs through millions of simulation to optimize production based on some business requirement. And then also can go into the ability to manage against carbon emission, for example. So all these things can come into play and really optimize production, change the way we work, such that we can produce, cleaner energy at a more efficient rate. It also helps us clearly with exploration, but we aren't quite there in terms of this cognitive AI. We'll kind of rely on quantum computing as we go forth, but we're very close to that. That's the work that I mentioned. I've been working with academic institutions like MIT and Caltech on some of these leading areas to embed what we have rolled out in terms of a digital twin, but now putting the intelligence behind it. We're gathering all the data, making it contextualized. Now we want to be able to get artificial to help bring that together and be more than just present the data, but actually recommend, and then in some cases take corrective action as necessary to meet business objective. So I think the opportunity is huge to be able to really dramatic the way that we actually produce energy going forward.
All right. Thank you, Ken. Reza, building on that, so Ken was talking about some of the great potential for artificial intelligence in the energy industry, but I believe there's also some pitfalls in deploying artificial augmented intelligence in the energy industry. What would you say are some of these pitfalls?
Yeah, I think both Manas and Ken, they had like great visions and great added values to the answers that they had. And we like in this panel, we talked about the distant future AI that is fully automated. It has the unsupervised capability of identifying knowledge and the usability of that knowledge on its own by just system integration, which is great. But Manas also touched on this point that we need to have human in the loop. And one of the pitfalls of having AIs, specific narrowband AIs, is when we come to experts or SMEs that they are users of these AI systems, right? If they're not fully autonomous and we need to have somebody in the loop, they can easily be overwhelmed. And the organizations within energy that they have deployed several AI models and even analytics dashboards, etc., they may be feeling that their SMEs are getting overwhelmed with the amount of information that the AI is providing, with the confidence, with all of the parameters, right? And this is natural. This has happened in tech industry. This is also right now happening in the banking industry and financials and fintech, etc. So we need to bridge that gap. And for that gap, the AI systems, they need to be integrated into the business workflow, that they learn from the interactions of the SMEs, the way that they're doing their job with whatever method that they're doing it. It can collect information and can learn from it. And what comes out of that process eventually, which I think is going to be the future generation of AI before we get to the fully autonomous ecosystem, is about decision modeling. So an AI model or a set of AI models that can model the decisions and the outcomes, and they can provide recommendations to people who are actually operating or building a facility. And we're depending on the organization, some are way behind the curve, some are still trying to figure that out. But eventually, everybody will get to that wall that they need to go after recommendation systems and after that decision modelers, before go fully autonomous AI.
Thank you, Reza. Abul, I know you've done some work and not just developing of AI, but the actual scaling and the implementation of AI at scale in the oil and gas industry. Specifically, when it comes to scaling, where do you see some of the challenges?
Yeah, thanks a lot, Marijn, and I really thank you so much, three of you, Manas, Ken, and Reza, setting the scene for this pivotal question. I think the true value of AI, to that matter, what falls within it, machine learning or augmented reality, can bucket many things. But the real value realization will come, I would believe most of the panel will agree upon, only when we can scale. Scale here means has several dimensions. So I just wanted to bring some aspects of it. Please, my friends here, chip in if I miss anything. So with the experience that we see, at least in Equinor, like most of you, we have been this, let's say, digital transformation journey. We've been to digital for many years, but actually really focused. Really, we want to be a digital leader in energy transition. This is what our CEO, Anders Opedal, has given us a challenge. But we see that the first part of scaling artificial intelligence, machine learning application in an asset-heavy industry like us, we need to be fair with our industry. This is a legacy industry. First of all, that's the starting point. The data is the currency of this business in the data-driven world. So you need to get your data in place, in right order, with right governance. We can speak hours on this topic, I'm sure all of you. So I think, Marijn, the first point is the data has to be analytics ready before you even think of scaling. So that's where it started. So you do the housekeeping. You can do a lot of stuff in that space. Once you get that, what we also experience, the IT infrastructure. That's also a very interesting experience as we are learning as an industry, becoming more data-driven. We see that we have a very sophisticated IT infrastructure, but that's a legacy system. And now we are all moving to cloud, right thing to do, but it also comes with challenges. How are you going to interact with external? How are you going to deploy your models? How you enforce MLOps? There are so many topics around it. I think sometimes we kind of underestimate how much time and actually investment, real money needs to be put into in day-to-day operations to upgrade your system. That is one of the tasks I think all the majors are concurrently doing. Once we are at that place, and I would argue that oil and gas industry it's not the most attractive place for the top talents. Now, when we want to be data-driven as an industry, or you want to scale AI application, this is not always just like a job. I used to be a geophysicist before. So have a geophysical data, geological data, you want to plan a well. I've been doing for years. But now suddenly we see that when we are asking application or scaling AI application, you need multidisciplinary approach. You need multifaceted talents. And I would say that, the talent scarcity will bite us. I think it's already biting some of us, I'm pretty sure of that. But that's another dimension. And then the elephant in the room is the change management part. Okay, all of us here are very AI evangelists, I always call them ourselves, we believe in it, but is there really the people in the assets where Marijn is probably very active to engaging with? Are they really ready to accept your solutions? Some of them have been working with, let's say, non-AI fashion for decades, and they have been very successful. We have been finding billions of barrels by using 1960s technology. Now, how you transform the mindset of this greater folk, the greater number of people on the business line to accept your scale solution. I would also argue that this is a major challenge organization is facing and will face as we go into from proof of concept, some pilots, limited scale, towards a truly scalable, automated solutions where we can generate values. So Marijn, so those are the 4 or 5 dimensions I think is worth for us at least checklist very early on when we are thinking of scaling AI applications.
Great, thank you, Abul. And Sara, let's touch on actually the 5th dimension that Abul mentioned there when it comes to the scarcity of talent and scarcity of skills. I've heard people say before that basically a lot of the oil and gas industry does not feel that they have the right skills in this AI transformation. In your experience, what are some of the things that leaders in our industry can do to help cultivate the skills needed to realize this value?
Yep. No, absolutely. I mean, everyone's, talked about the importance of the human element still in being able to drive successful AI initiatives. And I think the first thing that it's important to realize is that there are shortfalls and demand for these types of skills in all industries, not just the oil and gas industry right now. So I think oil and gas players really need to think about putting in place strategies to focus on retraining, reskilling, and upskilling of the existing resources, and not only on recruiting new resources. I think there's many things that you can do to make sure that you have a solid reskilling strategy in place, but I would maybe mention these 4. So the first one is really to be very thorough in prioritizing AI initiatives that you want to undertake. Make sure that these initiatives are aligned to your business strategy and focus only on those initiatives that bring the most benefits to the organization. The second thing I would say is that I think you need to identify what are the skills that are necessary to deliver on these initiatives. Do you need business analysts? Do you need data scientists? Do you need process experts to focus on the process before you do anything else? Or do you need engineers that can help validate the data? The third thing that I would say is you need to define which of the skills gaps you have and need to fill. So I think there's two different kinds of skills gaps. Sometimes the second one is a little bit forgotten in more technical environments, right? So the first one is really focusing on the technical skills, such as product and process expertise. But then just as important, I think, is ensuring that you have people that can fill more of the, what they call the soft skills, right? Things such as analytical thinking, problem solving, and flexibility. This really helps to create dynamics within a team where you're bringing two different kinds of expertise and able to solve problems and bring solutions a lot faster. I also think it's important, though, to think about working with partners where you don't have the right skills in-house, and thinking about how you can leverage those partners to supplement your organization and supplement those skills. And finally, I would say many people have a little bit of a piecemeal approach to doing training. I think it's extremely important to make sure that you have a training plan in place and that that training plan helps address the skills gaps that you have. And you need to be able to have concrete ways of measuring progress and outcomes. And I think it's important to identify ways of measuring outcomes that are not just based on training completion. Oh, I did the training and therefore I have a qualified person, but more on the applied learning aspects. So does that person really understand what it is that they're attempting? So I think those are some of the areas where I'd really start to focus in terms of skills.
Great, thank you. I'd like to stay on this topic a little bit longer and first go back to Abul. Hey, you posed the challenge. Do you recognize some of the potential solutions to the challenge that Sara mentioned? And are there things that you think you could apply in your daily practice, or do you have a completely different solution possibly?
Sure. I think, as a leader, we should appreciate that we do not only come with problems, but rather we come with solutions. So let me see whether I can convince you. I think, Sara, absolutely to the spot. I think one point resonated a lot, reskilling, a very critical one. I think grass is not always green. We have repeatedly learned that, getting a blanket check of recruiting new data scientists or data professionals in a very specific domain like exploration or subsurface, it takes a pretty long time to understand, subsurface. So I think we really need to make sure that we're upscaling, reskilling our people. So I really want to emphasize about that. And also there is a good news here. I think whether people, the subsurface or oil and gas professionals, I think everybody's understanding time has come for a change. The world has changed for sure now after the pandemic, if we had any doubt. So I think there is a goodwill right now. We see it also in Equinor. There is actually a pool now that people really looking for opportunities to learn themselves. So we need to really accelerate on the space. I'm very passionate on the data space, Marijn, if that's okay to mention as well. I think this is sometimes underestimated. We need to have the solutions that we really need have to be software solutions, or we call data ops. It means that we really need to have almost an end-to-end solution to extracting your information, to contextualize them, to make them generalized, and then only you can apply advanced numerical techniques like AI solutions. So I think there are already lots of major enterprises are working towards it. We also see there are some innovative enterprising coming out in the marketplace. That's also very important. So we need to interact as an industry from the external world. And Sara, you also mentioned one topic, the external collaboration, extremely important. We clearly see that most of the innovations are coming not necessarily always from the oil and gas, rather from finance, rather from retail, from business intelligence. We need to be very selective and choosing some of the partners and actually go deep. make new collaboration. We start to think about in terms of ecosystem. So if everybody is better in the ecosystem, we are better. So I think that would be, and of course, I think the cloud journey is becoming a cliche. I think most of us in the industry is on the journey, but I believe this will be also not a blanket check. I want to mention that analogy again. Cybersecurity, serious stuff. As we go in the cloud, some of our information will be more exposed. So I think we need to really be conscious and actually take actions to make sure that when we are operating over the cloud and collaborate with external, very sensitive that we are following our guidelines and try to be very vigilant at every given time. So that would be one other. And the last point, I will reiterate that we must attract talents. There is a competition, Sara, you have mentioned, not only oil and gas. Every industry is suffering from it, and there is a fierce competition. We need to be the choice of employer for the new generation, and that means that lots of talents actually wants to work for organization with purpose. They want to do something bigger than they are. So I think we just need to be sensitive, have a very, very strategic mindset when we're actually going into the markets to attract talents. So I hope that some of the things, I think at least enterprises like Equinor is actually vigorously pursuing at this point in time.
Thank you for that, Abul. You touched on a few different topics. I want to come back to the topic of cloud and cybersecurity in a few minutes, if that's okay. And Manas, I'd like to hear your view. But before we do that, I just want to close off on the skills portion. Reza, how in Apache, how do you deal with the shortage of skills in artificial intelligence?
That's a very good question and definitely a challenge. So on that, primarily, I've seen data scientists, ML engineers across the domain, not just oil and gas, like in different industries, and I have probably like weekly talks and conversations with a lot of really good talents here and there. And one thing that oil and gas really, I think, needs to work on in general is to be able to clearly pose the problem and the challenge and the value add for the new recruits, right? So when we have like a specific problem, knowing what are the components of that problem, what are the exact challenges we need. Sometimes even within an organization, like Abul mentioned, you can train up a few of the employees to learn the specifics, and you need to always have that, I wouldn't call it a middleman, but like a project manager that has the domain expertise of the subject that can help, right? So there is a specific model that a few of the tech companies have started using, and it all started from Spotify as another company, that they run as a pod model, right? So they put a project manager, they put the talents they need within that team, like two ML engineers, a data engineer, et cetera, depending on the feature or project they want to work on. And that project manager has domain expertise and might not be a full stack data, like a machine learning developer, but he knows enough from every single subject area that can give clear instructions on what is the value add on the business side. He understands that very well and how they need to pursue, but not in details, right? So the details are left out to the engineers. I think we have a long way to go still to be able to attract talent, and it's not unique to oil and gas. Like a lot of companies out there that their primary business is advertisement, they are having problems attracting talent, and they're really big companies, tech companies out there that the top talent do not want to go out there. Especially after COVID, people want to work on, as was mentioned, on things that are bigger than themselves, right? So they want to see the value they're adding to the organization, and not that, but they want to see the value they're adding to the whole, let's say, energy in this case, and sustainability and things of that nature. So that's what comes to my mind, and I'm eager to learn what other people on the panel talk about this.
Thanks, Reza. And I also want to thank Eva for asking a question in the comments. I do want to stick on this topic a little bit longer. Eva, we will get to your question. But first, since Abul, you were talking heavily about ecosystems. Reza, you were talking about the importance of having somebody who understands the business problem in the team. That brought me back to Ken, your original answer, where you talked about working with academia. Now, when you're working with academia, how do you make sure that you bring in that sort of domain knowledge from the industry into the conversation? How do you make that work?
Right. So I think academia is good at research, right? So they provide kind of forward thinking much further out, and it's important lens because what I think what we're trying to do is to have a vision. But in order to get that vision, you got to build these steps to cross. There's a chasm of where we are today and where we want to be. So we're trying to build a bridge that gets you over that chasm to this end state. And so what working with academic helps to do is say, all right, what's possible? Some length out, 5-10 years, whatever. And then we work with the industry players that are today in the market working with it, and say, all right, so that's where we want to get to. How do we take these incremental steps? So what we've done is we want to incorporate those discussions in, right, as part of the conversation. We want to define what that strategy is, what that vision is to get what, like I said, if for example for us is to get to this self-healing, self-operating facility. Now we bring in industry players. Academic really they don't go beyond kind of prototype and etc. Right? They want to hand it off to industry partner. So we bring them in together and say, all right, Equinor is going to help drive what the vision is, and we bring in the appropriate industry partner and say, all right, help us build this bridge so that we can cross the chasm to get to this end state, and so it becomes more tangible. Because oftentimes, we have this vision that people will feel like it's pie in the sky. It's kind of space age. It's for science fiction movie. But if you are able to build these steps, because you have industry expert come in and said, here's the technology is available today. Here's what we're working on. Then I think by bringing closing that loop in, then not only can we bring kind of the broader industry knowledge in, but we can also sell that internal to our own company or other companies, because I think Abu mentioned it's important for the people who are working on it to believe that it's actually something real, not something that is just will never happen. So I think so. What I would recommend is that bring the conversation in early on with the industry partner and working with academic industry to make the vision a reality, or at least a pathway to that vision, not just have a grand vision and not have concrete step to get to that vision.
Great, thanks, Ken. And I see from everybody nodding in the call that the panelists are in great agreement with you. I am going to switch gears a little bit because we have a few different topics to cover. And Manas, I'm going to come back to you if that's okay. Building on the point that Abul made earlier around, hey, when you're going cloud in a big way, what does that mean for sort of cybersecurity, the challenges when you're in sort of operating oil and gas facilities, and maybe even taking it one step further, when you don't just have one cloud system, but maybe 100 or 1,000 edge devices, how do you then manage your cybersecurity? Do you have any experience there? Do you want to comment on that, Manas?
Right. Thanks, Marijn. So I think at Intel, we look at the cloud journey as like, how do we make sure our customers and partners have this unified compute experience as they move their workloads from on-premises to cloud or from edge to cloud. So, this whole hybrid compute, we provide that by having a unified silicon. So, Intel, people think of us as a silicon provider, and yes, we are. And so we have, a seamless experience for you from edge to the cloud with silicon that works at certain power and compute requirements in the very edge, the far edge of your data pipeline, to all the way the beefier CPUs that we have in the data center. Now we go one step above the silicon. So infrastructure is another layer. There's the software that sits above the silicon. So this is also something very seamless across edge to cloud. So for instance, we have a lot of open source software stack in AI. For instance, OpenVINO, for instance, TensorFlow that is Intel optimized, that spans across your edge to the cloud. So that's basically the aspect of moving your data or your workloads from edge to cloud or on-prem to the cloud, making it as seamless as possible. Because what we have seen, and different market research have backed that data, that it's a split, based on which market report you read. It's a split between how enterprises are treating their data between on-prem and cloud. Some say 40-60, 50-50, 70-30, but bottom line is you're gonna have on-prem as well as cloud for foreseeable future continue as is. So we want to make sure that the partners and customers have their seamless experience. Now, on the point of cybersecurity, we take it very seriously, right? So what we do at Intel, we provide secure enclave within the silicon itself. So this is a hardware secure enclave that is inbuilt into the silicon. So it's not a software solution for your security, but it's a hardware solution. So that becomes a lot difficult to break. So we have a homomorphic encryption to trusted execution providers like SGX that are inbuilt into the silicon. So it becomes really hard. And for applications like federated learning, where you need, like the whole point of federated learning in AI spaces, that you don't want to see somebody else's data, but still learn from that data so that your models can be smarter. Without a hardware-based security, that becomes really difficult, because you can have software solutions that can secure your data pipelines, but at times we have seen that they break. So at Intel, we work with our customer and partners to make sure that we increase the size of this secure enclave so that your whole data pipeline can fit into that secured part, hardware secured part of silicon, as opposed to just models or limited capacity in the memory size. So that's how we see providing the security as people have mentioned in the panel. Your data is lying from edge to cloud. So providing security wherever your data and models are is what we see from Intel's perspective.
Thanks, Manas. Now I'm going to go to the questions from the audience, and I want to start with you here, Sara, if that's okay. Because you do see multiple operators in our industry, and where do you think are the processes that can best be accelerated by applying artificial intelligence, and how much of a difference can it make?
So obviously, I have a professional, deviation. I've worked for most of my career around services and field services. What I have to say is that, sort of in reading a lot of information on artificial intelligence in the oil and gas industry, it's still very focused on those, core processes, whether it's exploration, where you're really managing massive amounts of data and so forth. But I think somebody alluded to it earlier. You can focus on the big projects, or you can also focus on things that are more of a quick hit, right, for an organization. And I think areas that are much more of a quick hit for an organization in the oil and gas space is things like leveraging asset data. So the asset data that you already have today, that might be asset history, bill of material data about what parts are you changing out most frequently on your assets, and so on and so forth. Combined with that human element that we talked about also earlier, you have field service engineers in the field, you have asset managers, you have reliability engineers. These guys know exactly, what breaks, why it breaks, when it breaks, and what are the most frustrating things for them to fix and go after. So all of this to say that I think one area where there is an opportunity to get a lot of benefit much more quickly, I think, is around the area of asset management and being able to move from a reactive to a much more predictive model of maintenance.
Great, thanks, Sara. Reza, in Apache, do you also see that indeed predictive maintenance is one of the key application areas for AI? And do you see any other processes where AI can make a big difference?
Absolutely. I think especially on the operation. So we have AI models that are helping, and right now, even internationally, on all of our drilling operations that Apache developed with a co-collaborator from the industry, and they have deployed it. But especially at a scale of the number of operations, especially within the production operations realm, we have developed and deployed several modules, and predictive maintenance is definitely one of them. The other areas are, Sara talked about like the service team, or like the field team, what we call them. They know exactly what breaks and how they need to run their business. But due to COVID, even before COVID, a lot of organizations are really lean, right? So we have close to 20,000 locations just on US North that, like several hundred, or I don't know, 1,000 something of field personnel, they need to look at each of those locations. And if we wanted to use our traditional model, the way we have been running it 2 years ago, they have to look at every single one of them every day. So we looked into the market. There was no product that was fitted to the challenge that we had. And Apache took on about less than a year of development to build a product that just orchestrates and automates a lot of works that those people in the field, they need to do, to just be able to monitor, provide service to the right locations at the right time. So instead of looking at everything, every single location every day, now they can look at less than 10% of what they are allocated to. But the production, the maintenance, everything is already taken care of in that sense. So the production profiles, they have not declined. The cost and maintenance cost, it has drastically reduced because of like these kind of solutions at a scale that it's a combination of augmented intelligence plus artificial intelligence to some extent. So it's not a very too much complicated deep learning model at all, because there was no need for that. But still, some people call that an RPA, robotic automation, right? When you talk about augmented intelligence, like that's part of it, right? These kind of solutions, like at a scale, they are really, really needed for production operations. Predictive maintenance, definitely. The scale of data for predictive maintenance is so huge. Like, just look at the compressors. Like, we're now looking at our emissions, etc. Right? So these are really, really important things that AI can help. And it's impossible to have, I don't know, even hundreds of people that are looking at the stream of data every second, and they are supposed to make decisions based on just looking at the data.
Hey, Marijn, can I just add real quick?
Reza, Ken, go ahead. Yeah, go ahead.
Just real quick. I think what he mentioned, predictive analytic, is so critical to building the future of AI, right? In terms of the cognitive. So across the board, in order for us to evolve into a more automated system, predictive analytics got to be in place, right? So one of the things, as Reza mentioned on that, but you look at corrosion, integrity management. If you're able to predict when something goes corrode, then you're able to take action before it goes corrode. So I just want to add that, yeah, so predictive analytics right now is so critical to make sure that we are fully rolled out and they understand how things will fail or how we'll operate, whether it's flaring to integrity management, whatever. It's so fundamental. It's one of those building blocks I mentioned in order to get to kind of the end state that we want to get to, which is a more fully automated system. So anyway, I apologize to interrupt.
No, not at all. I was actually going to ask you next to say, hey, where do you see some of the most successes? So all good. Abul, in Equinor, where do you see some of the biggest areas of application in terms of work processes?
Yeah, I mean, for Equinor, we have consciously decided to have a kind of enterprise deployment of let's say AI applications. So you can virtually think we have a very large value stream. As you know, traditional oil and gas, we are pretty well positioned in the offshore wind, in low carbon solutions, hydrogen, you name it. So I think our application is, or our way of deploying, AI application is quite pervasive. But of course, this has also some pitfalls. Being really want to do big bang, but also some of the things what we clearly see is. I would try to actually shift the gear a little bit. It's more about empowering So, we can develop some very specialized AI solutions. But also, remember, we are also sitting on a very large pool of existing talents, or not necessarily a data scientist per se, but they have quite a bit of scientific background. So one of the initiatives where I'm personally very engaged is more like how to empower this mass of professionals that we are sitting up on, working together to find the state-of-the-art tools, to actually essentially creating citizen data scientists or citizen analytics. So that's also another part of our upskilling, reskilling, which Sara was alluding. At least that's one part of it. Predictive maintenance, just to carry over that part, definitely digital twin. We see digital twin application not only in our traditional oil and gas, clearly very good potential in offshore wind assets management, for example, and potentially to other new business areas. But also, and the core of what we do is our digitalization effort is quite, we believe that we're in a strong position when it comes to the subsurface analytics, essentially let's say the exploration part or oil recovery. Those spaces, they're also highly data rich domains where we are gradually progressing towards more generic, generalized AI applications. So those are more short-term, mid-term value realization that we see clearly happening. And also, I can go over the list, but I would say that our approach in Equinor and we're going over the whole spectrum, but of course, collective, and also with a very, very strong collaboration with the external ecosystem. So that's our strategic decisions. We want to think around ecosystem. We want to work together, as you mentioned, educational institutions, industries outside oil and gas, traditional suppliers, and also partners like operators or suppliers alike. So I think we are thinking about this more, let's say, a more holistic approach to scale AI applications in Equinor. Yeah.
Thank you, Abul. You mentioned the term digital twin there, and I know there's a lot of energy for combining artificial intelligence and digital twins. So I want us to spend a few minutes just digging a little bit deeper there. I'm going to start with you, Manas, if that's okay. In your experience in the oil and gas industry, once you have a digital twin in place, sort of, what does it enable? What are the next steps? How do you go from there?
Right. So I think having digital twin is not the end game there, right? I mean, what we really want to reach is the state where this becomes like a like a lean methodology workload for you. So basically, you can test and refine what works, what doesn't work. Like think of a digital twin of systems, right? And can you do a prescriptive analytics to basically reduce the carbon footprint of the whole facility, right? And what needs to happen in order to do that, right? So that is the state where we really want to be eventually with digital twins. I think we are getting there. The very first step is having this digital twin of the otherwise tangible facilities and assets, which I think we have already established, and I think Ken probably would have more to say on that. But the future is where we could do some sort of prescriptive analytics and test and refine what works, what doesn't work, with one or two common goals in mind. One, reduce carbon footprint. Two, reduce energy requirements, or whatever the business needs may be.
Ken, Manas just suggested that you have more to say on the establishment of digital twins in our industry. Is that indeed the case? Anything you'd like to say about, hey, what is enabled by having a digital twin in place?
Yeah, so digital twin, I can give a concrete example. We're rolling that out obviously across BP, but especially we have an asset that is in the process of finishing up and starting up in the short, and we're able to start from kind of the early stages, right, to essentially build the data right and get that out, and we're trying to roll that out to other assets as well. But by having a digital twin out, it's fundamentally changed the way we operate and build, or build and operate, right? That can go from how we design, how we inspect, how we commission, and now we're close to the operation. So what's for example corrosion, as I mentioned a while ago. We're looking at corrosion. Traditionally, you require people to go out and inspect this on a regular basis, right? Because particularly if you're offshore in harsh environment, this is a natural piece of it. But with the ability to have a digital twin in with predictive analysis using laser scan and photogrammetry, we now can use machine learning and artificial intelligence to detect when corrosion will begin to occur, because you're looking at the profile, the pitting, the blistering, and now you can say, yeah, that piece on that line is going to corrode over the next 6 months. Let's go and address it through fabric maintenance, by painting it, etc. So that's one example where we completely use the digital twin, contextualize data, use artificial intelligence to be predictive and prescriptive, to go and take step before it occurs. Now we can strategically manage our resources, save carbon footprint, and take action before it creates a problem. So that's just one example. There's so many other ways that we are using the digital twin to really change. It could be competency assessment, how we assess people for training. It could be from the way that we do spare parts to the way we optimize production efficiency on it. So I think once you have the data right, and I think the panelists all mentioned, you have to make sure you have the data right. Then you are able to kind of build upon that. The next evolution, I would say, is, as I mentioned, as we get to kind of cognitive artificial intelligence, is how does an AI system take what you have, and even if you didn't have the data quite right, is go out and probe human beings to get the data right. Right? That's the next evolution. We're not quite there yet, but I definitely do see that very near in the future, being able to do that. So I think these steps are enabled by having a solid platform like a digital twin to allow you to contextualize the data, to pull it together so a human being can kind of validate. Because there's a huge step between handing over the keys of the kingdom to a machine from where we sit. So you got to go through these incremental steps.
Thank you, Ken. And Sara, I think some of the topics that Ken just touched on are close to your heart. Do you see in practice that digital twins are already supporting sort of predictive maintenance efforts, service optimization efforts? Do you already see that in practice, and if not, what do you think is necessary to really get that value out from them?
Yes, I think they are in practice. I think it's obviously COVID has accelerated the use of technologies such as digital twins, remote monitoring and diagnostics, remote technical support, and these are having an impact. I recently talked to a customer, for example, who was saying, well, our resolution time on cases on remote technical support has gone up by, I don't remember what the percentage was, but X%. And he said, however, our first-time fix rate has improved on the assets, and our truck rolls have gone down. So that means that the application and leveraging this technology is becoming better all the time, because we're able to resolve more issues remotely. Or if we do need to go in the field, we have better information about what parts, what technician skill sets are needed, and so forth, in order to be able to resolve those assets the first time, right? And all of this has an impact, obviously, on asset uptime, on asset reliability, and ultimately reducing and containing maintenance costs.
Thank you for that. And I think we've all mentioned it. Data quality is absolutely essential. But I want to spend a little bit of time, as probably the last topic we'll touch on, spend a few minutes on talking about some of the ways to ensure that you do have good data quality, and what are some of the practical solutions to ensuring that we have good data in our industry. And maybe Abul, I'll start with you on this one. How in Equinor do you guys work to ensure and verify that you do have good data to then enable your digital twin and your artificial intelligence journeys from there?
Sure. Again, this is a very broad topic, but let me try to. So our approach is in Equinor, we at the very beginning, we realized, we need to have the things under control. So the strategy has been very clear. We have implemented, it's our own data platform. We call it Omnia. which is we're working very close with the OSDU, Open Subsurface Data Universe, for this industry standard. So that's also, again, very important. So our data liberation journey is that we want to do it together, because just having my, sending, let's put it this way, dumping all the seismic data in the cloud is not rocket science. The question is how you're going to do it. Can you use it with your partners together? Can the external ecosystem can find the best possible apps that we can absorb? So I think that is a very strategical discussion. So our step has to be that, we need to get our data platform in place. And then, of course, the part of collaboration. So that's happening. There are several options that are there. But also we took another deliberate approach. Is again about it's about push against the pull. So let me build on this. So assets, at least in the Equinor setup, is owned by the asset owner, in this case, major installations or fields. So not always your assets are actually on the same pace as the other digital organization are. This is just a reality. That's why you asked, Marijn. So we also see that some of the assets are very eager to push their data to the crowd, or in some of the assets that the central organization need to pull it up on behalf of that. That's also part of the equation, actually, because this is how real life is. In addition, we also, for the data liberation task, it's also been use case specific. Not every data is equally important at a given time. There are some business needs. So there has been a prioritization. It's an ongoing priority, actually, because the business environment changes, so the priority changes. So lots of the data lifting and shifting and contextualizing is happening around the priority. What is our board, let's say executive committee, wants us to achieve? Low CO2 footprint. So then look at that, which assets is creating the most negative effect. Let's go there. Pull that data first, apply algorithms and find solutions. So these are like a kind of some of the very large scale, let's say very helicopter view of some of the efforts that we have put into place, Marijn. And it's a journey.
Right.
It just, yeah.
Oh, thanks, Abul. And maybe as a final question to you, Reza, how do you see this? What are some of the things that you have done to prioritize the data cleanup and then actually make it happen in reality?
Yeah, there are two things here, because we talked about two subjects, like the digital twin and AI. In my mind, these are complementary, but they're not exactly the same. So for digital twin, my personal belief is that you don't need to have your data 100% clean, because you can build a system model at the 30,000 feet view of the ecosystem, right? So what managers and executives want to look at as a system end to end, and then you can start building hypothesis and model system at a larger or higher scale, and then have collaboration with your engineering team so they can build agents, right? So this is like a design of agent-based modeling, a decision modeling, that they can build the details, and then that's where the AI component comes in. You have to build models around your facilities, your compressors, your pumps, et cetera, that you can fit into it. But you can still make decisions without all of those details with limited clean data, right? But when it comes to cleaning the data, if your data is not clean, right, and that's our assumption here, what at Apache we have done is we have built a system, an automation system for the SMEs to be able to do their daily job, right? And we realized that some of our, let's say, production engineers, they have been looking at 3 or 4 different tools to be able to do their job. Like they check a portion of data on this tool, another portion on production data here, and the ESP health or compressor health here and there, right? We aggregated these tools into a better one that it's one place that they can see everything. And then what we have done is that we have told them that wherever you see something's incorrect in the data, you can fix it. And we have built a pipeline in the backend that validates that data. It even collects the user interactions, what plots they look at, how they look at it, how the data streams are going. And it helps with the cleaning of the data, at least tagging them. And after a while, after we had like human validation, they would validate and then change the source snapshot of the systems. But then after a while, the issues were so systematic that we could easily pipe that data in. Even our AI models now, they learn in the backend from the user interaction. If they are tagging that they have a specific issue on a specific pump and that comes in frequently, the AI will realize that issue, and it will realize what are the data streams the SME was looking at when he made that decision. So it tries to mimic that behavior and be proactive in terms of tagging the data inconsistencies and data issues. So the SMEs don't have, initially they have to look at every single stream for a week or so, and then nowadays they can just see the tags, the potential issues with the data, and they just approve or disapprove that change for the data cleaning. So AI can help even clean the data for you because we have 3 or 4 flavors of AI that can help with that.
That's extremely impressive. I'd actually like to dig a little bit deeper, but we're at time, I'm being told. So I just want to say thank you to the panelists. We may even have to continue some of this conversation offline to continue learning from each other. Really appreciate it. I really enjoyed this session. I hope you guys did as well. Really thanks for your time, and thanks to Adam and the team for giving us the opportunity to have this conversation in front of a global audience. Thanks a lot.
Thank you all.
Thank you, Mark.
Thanks all.